So in this presentation, we have to talk about Klein equation. The Schrodinger equation we use to solve physical problems is of second order in space coordinates, but time is of first order. This contradicts the space-time symmetry requirement of special theory of relativity. If you see the Schrodinger time-dependent wave equation, h psi equal to E psi, h, the Hamiltonian operator, is expressed in terms of Laplacian operator del square. Then the value of del square is dou square by dou x square plus dou square by dou y square plus dou square by dou z square, which is in second order. Whereas the energy operator, which is equal to IH cross dou by dou t, here the time is expressed in first order. So this Hamiltonian is called as non-relativistic one. To solve this difficulty, Klein and Gordon introduce a new Hamiltonian called as relativistic Hamiltonian, in which both coordinates space and time are expressed in second order. The Hamiltonian is h square is equal to E square is equal to c square p square plus m square c power 4. This Hamiltonian is derived from the variation of mass with the velocity equation, where m is equal to m0 divided by root of 1 minus v square by c square. Squaring on both sides, we can get the equation of this form. Then if you cross multiply, m square c square minus m square v square is equal to m0 square c square. Then m square c square is equal to m square v square plus m0 square c square. Multiply the above equation by c square on both sides, we can get m square c power 4 is equal to m square v square c square plus m0 square c power 4. Here p equal to mv, so this term m square v square is p square. Then this square c square is present as h plus m0 square c power 4. Therefore, E square is equal to p square c square plus m0 square c power 4. Here E equal to mc square formula is used. In this way, we have arrived at this equation 1. Here m is taken as rest mass. In the above equation, replace E by the operator IH cross dou by dou t and P by the momentum operator minus IH cross delta. The equation 1 is modified in this form. We know that I square is equal to minus 1. So this is modified in this form, minus h cross square dou square by dou t square is equal to minus h cross square c square del square plus m square c power 4. Then this is further modified in this form. Minus h cross square dou square by dou t square is equal to minus h cross square c square del square plus m square c power 4 is allowed to operate on the wave function psi. Now we can get the equation of the form 3. Now divide equation 3 by minus h cross square by c, h cross square c square. We can get 1 by c square dou square psi by dou t square is equal to del square psi minus m square c square by h cross square into psi. By modifying this equation, we can get the equation of form 4 and is called as Klein equation. If you take psi outside, we can get del square minus 1 by c square dou square by dou t square within the bracket. This is called D'Alembert operator. So D'Alembert operator operating on psi is equal to m square c square by h cross square into psi. In this equation 4, if you see the space coordinates which are in second order and the time is also in second order, dou square by dou t square. So this is our Klein equation. Del square psi minus 1 by c square dou square psi by dou t square minus m square c square by h cross square into psi equal to 0. In this equation, you may see both the coordinates space and time are expressed in second order. If you want to develop the solution for this equation, the possible solution is psi of r comma t equal to e power I k dot r minus omega t. If you substitute the value of psi in this equation 6, we can get the eigenvalues. H cross omega whole square is equal to c square h cross square k square plus m square c power 4. Here h cross omega and h cross k are the two eigenstates. If you want to calculate h cross omega, then h cross omega equal to plus or minus root of c square h cross square k square plus m square c power 4, which means that the energy eigenvalue can have positive and negative values. But Klein and Gordon are not able to provide prompt explanation for the occurrence of negative energy state, which is a major drawback of this equation. Furthermore, The kg equation is not suitable for a particle with spin. It deals about spin-free particles like mesons. So the way of arriving the energy equation E square equal to h cross omega whole square, and p square equal to h cross square k square is explained as a hint. E equal to h nu, divide h by 2 pi and multiply nu by 2 pi, we can get h cross omega, since h by 2 pi is our h cross. This is our propagation vector k, which is equal to 2 pi by lambda, but according to de Broglie, lambda equal to h by mv, which is equal to h by p. Then k equal to 2 pi p by h. 2 pi by h is 1 by h cross, so this is p by h cross, then p equal to h cross k. In this way, we can get E square is equal to h cross omega whole square. Then instead of p square, we can put h cross square k square. The energy eigenvalues you can have. That's all about the Klein equation.